Welcome to the next tutorial on constant acceleration. Now, what I'm going to cover isn't exactly new from the last tutorial, but it's something you need to be aware of, and that is if your acceleration is down to gravity. Now, gravity on the Earth is 9.8 meters a second. Now, this number is quite important because you're going to be using it in a lot of different calculations. 9.8 ms to the minus 2. And this is something you'll need both in maths and physics. It's a number you should remember, although I believe they give it to you on exams. I'm not sure, but better safe than sorry. So all it means is that A equals 9.8 meters a second squared. Although, if you're throwing something up in the air, or you're going up in the air, you're going against the force of gravity, which is why we commonly refer to A as minus G, because you're going in the opposite way to gravity, and that's the main problem. So we're going to take a question, and that's all we're going to do, because there's literally no difference. You're just substituting minus 9.8 in for answers. So a ball is dropped at a 2 meter height find the time it lands. Now again, we're going to use the same principle. S-U-V-A-T. Now obviously there's some bits of this we do know and some bits of this we don't. So S we know is 2 meters because it states in the question. U does not have a value, so we don't need to, well, actually we do need a U because it's 0. V we don't know, and A is minus 9.8. That's all we need to know. We have 3, and there is an equation that we can use to help. And that of course is S equals UT plus half AT squared. So we'll substitute our values in. 2 equals 0t, but we'll scrap the 0t, plus half of half times minus 9.8 times t squared. So therefore 2 equals minus 4.9 t squared. And t squared is 2 over 4.9, and t equals 0.64 seconds. Obviously you can't have minus seconds, that's just weird. But yeah, as you can see, that's literally all there is to it. It's substituting in 9.8 or minus 9.8 as your acceleration and then using it in a Suvat equation. Thank you very much for listening.